Today we are going to learn about automating experiment tracking with DVC, focusing on setting up and automating experiment tracking to enhance productivity and accuracy in data science projects.
Welcome to our video on automating experiment tracking with DVC. In the realm of data science, maintaining a streamlined and error-free workflow is crucial. DVC, or data version control, is a powerful tool that enables data scientists to automate experiment tracking, ensuring accuracy and consistency across projects. Through automation, DVC minimizes human error and fosters a collaborative environment where data and model versioning are seamlessly managed. Today, we will explore how to set up and utilize DVC to enhance your productivity and accuracy in experiment tracking. DVC, or data version control, is an open-source tool designed to handle the versioning of data and models in machine learning projects. Unlike traditional version control systems that focus solely on code, DVC integrates data and model management, allowing data scientists to track changes and reproduce experiments efficiently. The core functionality of DVC lies in its ability to create pipelines that automate the tracking process, making it easier to manage complex projects. By using DVC, teams can maintain consistency across workflows, minimize manual errors, and ensure that every experiment is reproducible, which is a critical aspect of scientific research.
To start using DVC in your projects, you'll first need to set it up properly. Ensure that you have Git installed, as DVC works seamlessly with Git for version control. Begin by installing DVC using a package manager like pip. Once installed, navigate to your project directory and initialize a DVC project using the command DVC in it. This command sets up the necessary DVC files to start tracking your data and experiments. Next, configure remote storage to store your data remotely, which is crucial for collaboration and backup. Use the command DVC remote add to link your project with cloud storage services like AWS S3 or Google Cloud Storage. Finally, connect DVC to Git by committing the DVC configuration files. With these steps completed, your DVC project is ready for action. Data and model versioning are at the heart of DVC's functionality, providing a robust way to manage changes over time. With DVC, you can track data files and directories using the DVC add command, which adds your data to the DVC tracking system. This ensures that any changes to your data are recorded and can be reverted if necessary. Model versioning is equally straightforward. Simply use DVC add to track model files, and DVC will handle the rest. The versioning process in DVC allows for seamless transitions between different stages of your project, ensuring that you can always reproduce past experiments with the exact data and models used. This level of control is invaluable in machine learning projects, where even minor changes can significantly impact results.
DVC pipelines are a powerful feature that allows you to automate complex workflows in your data science projects. A pipeline in DVC is essentially a series of stages, each representing a step in your data processing or modeling workflow. To create a pipeline, you define each stage using a dvc.yaml file, specifying the inputs, outputs, and commands to run. Once your pipeline is set up, you can execute it using the DVC repro command, which automatically reruns only the stages affected by changes. This automation reduces manual intervention and increases efficiency, enabling you to focus on refining your models rather than managing experiments. DVC's pipeline feature ensures that your workflows are repeatable and scalable, ultimately leading to more consistent and reliable results. In any data science project, the ability to compare experiments and interpret results is crucial. DVC provides tools to facilitate this process through its metrics tracking feature. You can define metrics files in your dvc.yaml to automatically track performance indicators such as accuracy, loss, or any custom metrics. Use the DVC metrics show command to view these metrics and compare them across different experiments. DVC also allows for visual comparison by integrating with visualization tools, providing a clear picture of how changes in data or models impact results. By leveraging DVC's comparison tools, you can make informed decisions about model improvements and ensure that your experiments lead to meaningful insights. Integrating DVC with C/CD, continuous integration/continuous deployment, systems is a game changer for automating and streamlining data science workflows. By incorporating DVC into your C/CD pipeline, you can automate the testing and deployment of your models, ensuring that they are always up to date and aligned with the latest data. Begin by configuring your C/CD tool to run DVC commands, such as DVC repro and DVC pull, as part of your build process. This setup allows for continuous testing and validation of your models, reducing the risk of errors in production. With DVC's integration, you gain a robust workflow that maintains consistency across deployments, allowing your team to focus on innovation and improvement. Effective collaboration is essential in data science projects, and DVC provides several features to enhance teamwork. By using DVC's version control capabilities, teams can work on shared projects without overwriting each other's work. DVC's remote storage feature allows team members to access and update datasets and models from anywhere, fostering a collaborative environment. To manage shared resources effectively, ensure that all team members are familiar with DVC's best practices, such as committing changes frequently and using descriptive commit messages. By leveraging DVC's collaboration tools, your team can work more efficiently, reducing conflicts and increasing productivity in your data science projects. Let's explore how real-world companies have successfully implemented DVC to enhance their data science workflows. Company A leading tech firm, used DVC to automate their model training and evaluation processes. By leveraging DVC pipelines, they reduced manual errors and increased the reproducibility of their experiments, leading to more reliable results. Similarly, Company B, a healthcare analytics company, integrated DVC into their C/CD pipeline, streamlining their deployment process and ensuring that their models were always aligned with the latest data. These case studies highlight the transformative impact of DVC, showcasing how it can lead to significant improvements in efficiency, accuracy, and collaboration. By learning from these examples, you can apply similar strategies to your own projects and experience the benefits of DVC firsthand.
As we conclude our exploration of automating experiment tracking with DVC, it's clear that DVC offers numerous benefits for enhancing productivity and accuracy in data science projects. From version control to pipeline automation, DVC provides the tools needed to streamline workflows and improve collaboration. As your next steps, consider implementing DVC in your projects and explore further resources to deepen your understanding. We encourage you to start using DVC today and experience the transformative impact it can have on your work. Thank you for joining us in this learning journey, and we look forward to hearing about your successes with DVC.